Hello, and welcome to the second episode in the series I'm calling the IT Wildcard, where I take questions put in the comments section of the series from my long-suffering viewers about various aspects of IT. And thank you very much for the person that commented in the introductory episode in the comments section. If you want to know more about what this series is going to be about, I suggest you watch that first video where I sort of explain the context and a bit about my background if you don't know a little bit about me in terms of what I haven't already sort of ambiently given away in all the various other episodes I've done on the channel on various things over the years. So the question was about database shards, database sharding, I think the exact term that was used. So I've gone away, done a little bit of research, and I'm going to talk a little bit about this. This is going to be quite a helicopter view. It's like a top down. I'm not going to get super granular. And in a lot of these episodes, that's how it will be. If someone asks more of a programming question, that might be different. I may get a bit more granular on that, or people start asking questions about, I don't know, the registry or configuration files on Windows, then maybe in that case. But anything that's talking about like a server-based technology, where I wouldn't be able to set up a system quickly or even set up a system to do that, that's not something I can get super granular on. So this one's going to be quite top level. I'll include links from a number of different resources. So there's one from Amazon Web Services, DigitalOcean, a blog about how does database sharding work, one from MongoDB, and I'll leave this up on the screen while I'm chatting. So I'm going to chat a bit now about this. Once I've finished chatting about database sharding, I'll tell a little story about my own crazy experience in the world of database management systems from back in 1997, 1998, I think it might be, somewhere around that time. And quite a very stressful situation that I got into, which does involve, I suppose you could call it proto-sharding. So it was before the term sharding was used, but it bears very, very interesting similarities. So I'll leave this on the screen, and as I explain what sharding is, this will make more sense. This example is of a single table, so a single table database. Obviously, most of the scenarios you find sharding in, there are going to be multiple tables in the database. So what is database sharding? So it's a technique of splitting a large database into smaller pieces called shards. And in today's world, they may be or will be stored on different servers. Sharding can improve the performance, scalability, and availability of a database by distributing the load and reducing the size of each shard. However, and as soon as you start to think about this, where you're splitting up like a database into multiple containers, you're going to straight away realize there's certain challenges and complexities that sharding does. And those challenges and complexities you need to consider before implementing it. So yeah, that's something that needs to be obviously important. So database sharding is a type of horizontal partitioning, which means dividing a table's rows into multiple tables with the same schema and columns. So you can sort of see that very simply expressed here. So here's our original table, and you can see it's basically just a product and a price, and it's been sharded. I use the term sharded here. It's been sharded by price. So we now have some sharding going on. You can still, the basic scheme is the same, and it's got product price, but it's just been sharded into these groups of prices. Now that's not the only way you can shard something out, and we'll talk about some basic categories of sharding in a moment. So each table is called a shard, and it contains a subset of the data that is unique and independent from other shards. Shards are then distributed across different servers called physical shards, which can host one or more logical shards. So you can have physical shards, you can have logical shards. The server use the same database engine and hardware type to ensure consistent performance across all shards. Sharding aims to achieve a shared nothing architecture, which means that each shard is autonomous and does not share any data or resources with other shards. Now we'll come on to a problem with that and why that might not be achievable. Now the idea of shared nothing architecture, while that reduces the risk of a single point of failure and processing bottlenecks, you can see the problem if, say, this becomes unavailable. Okay, these are still available, but you can't do any lookups for widgets or whatever that is. So in some or many cases, it may make sense to replicate some tables across all shards, particularly where they serve as some sort of reference table. So for example, you might get a database that contains some sort of conversion table for different measurements that are used in a lot of different queries, they're used by a lot of different tables. And so it might be beneficial to copy that particular table into each shard to avoid cross-shard communication where that would be a problem. You usually find that sharding is implemented at application level, which means that the application code decides which shard to use for each query based on a sharding key, but that's not always the case. And a sharding key is a column or a set of columns that determines how to assign a row to a shard. For example, if a database contains customer data, the customer ID could be used as a sharding key to distribute customers across shards, but that's not the only way. And you probably can see here, if you know a little bit about primary keys and indexing, you probably can recognize there's scope there for sort of mapping some of that to a shard potentially, or a shard key, a shard index, whatever you want to call it. So as I've said, or as I've sort of alluded to, one of the main benefits of database sharding is that it can facilitate horizontal sharding, which is also known as scaling out. So horizontal scaling is a practice of adding more servers to an existing system to handle more traffic and faster processing. Horizontal scaling is more flexible and cost-effective than vertical scaling, which means adding more CPU and RAM to a single server, or I suppose also adding somehow more disk space to a single server. I'll come on to disk space in my little story and why I've even brought that up. Vertical scaling has physical limits and can become very expensive as the data grows, and that's the thing. And we probably had a situation, anybody that's worked in IT, where our database has physically outgrown our server to the point where it's actually not possible to expand it, to scale it vertically. And that's one of the reasons why horizontal scaling is very appealing. I did a lot of academic work, I suppose, or studying when I was studying about web servers back in, I think it was the 2000s, when I was doing some distance learning courses on as part of a web development course on sort of database scaling and how you scale out with, say, web servers, stuff like that, and the different calculations you have to do if you want to get a rough idea of performance. It's a pretty interesting course, actually. So by sharding a database, each shard becomes smaller and faster to query. It improves the response time and throughput of the database. Sharding will also allow, as a sort of consequence of that, a parallel processing of queries across shards, which can increase the performance even further. Additionally, sharding can improve the availability and reliability of the database by reducing the impact of failures and allowing for easier backup and recovery, bearing in mind that's dependent on how things are sharded up or what tables might be replicated and what ones might not be. So what are some drawbacks? So obviously it's not one of these cure everything situations or solutions for database problems, because it also introduces some challenges and complexities that need to be thought about before implementing it. And some of these are things like sharding requires more infrastructure and maintenance. It involves managing multiple servers and databases instead of one. This increases the operational overhead and complexity of the system. Sharding also requires more network bandwidth and coordination among servers. It can affect data inconsistency and integrity, because as I've said, you can get data anomalies, inconsistencies used to latency and concurrency issues amongst the shard. So, example here, if you've got two transactions that update the same data in different shards at the same time, one of them may overwrite the other without knowing it. To prevent this, sharding requires implementing mechanisms such as distributed transactions, locking, or eventual consistency. And of course, a lot of things like data locking are already in place on databases anyway. And certainly when I worked for a evaluated reseller doing accounts rollouts where the back end was a database system, there was obviously locking on databases while transactions were being entered. And it's obviously something you particularly find on accounting systems, but other transactional systems as well. Sharding can complicate queries and joins, so that's something you need to think about. So it can make queries more complex and less efficient if they need to access data from multiple shards. And this is where replicating certain tables might alleviate that, but not always. So if a query needs to aggregate data from all shards, it may need to perform cross-shard communication or collect partial results from each shard and combine them at an application level. And also if a query, say, needs to perform a join from different shards, it may need to perform distributed joins or potentially do something with the normalization of the data. Sharding can also bizarrely limit flexibility and scalability. Because of the act of sharding, it might make it a little bit harder to change the schema and add new data features to the database without impacting all the shards. So if you had, say, need to add a new column to an existing table, how is the system going to handle that? And again, that, of course, that's dependent on what database management system you're using, and we'll come on to the differences, the broad differences between how easy or not it is to do sharding based on what sort of database management system you're using. Also, if a new feature requires accessing data from different shards in a new way, you might have to modify the application code or something to do with the logic behind the sharding. And sharding can also limit the scalability of a system if the chosen method doesn't actually distribute the data evenly or can accommodate for the growth of the data. Because you often find that this in IT is you might do something which in some ways has solved a scalability issue in one direction, but it affects a different scalability problem. So there's multiple ways to shard a database. And I suppose you can broadly divide these into a couple of categories, but I'm sure there's other ways of looking at this. There's multiple subcategories. But you can do it more based on range-based stuff. So this is a good example of that. Another way is called hash-based sharding, and I'll explain the two broad methods. But within the range-based sharding, you can have other things that are similar to it or are a subcategory. So I'm thinking of things like geographic-based sharding, where, say, the sharding might be done on, say, postcodes, or where you've got a database that is in multiple parts of the world. It might be based on, the country, something like that, country codes. So yeah, there's lots of different ways outside of hash-based sharding that are similar to range-based sharding, in that you're more based your sharding on a particular column or group of columns of a particular type of data, and that you choose based on really how you want your shards to be, how the shards reflect how you do business. Does your business have geographical considerations? Are there price considerations that lend itself well to being sharded that way? What's another good one? Like time-based considerations, maybe the status of an order. Maybe you want a shard based on, is the order complete? Is it in process? Has it been completed? Is it been completed, but it's such an old order, the person who has the account actually doesn't have an account anymore? And so you might elect to shard based on that. So as I've said, broadly speaking, range-based sharding involves sharding a database depending on a specific range of values. It uses a sharding key to determine which shard to assign a value to. The sharding database application checks the shard that corresponds to the sharding key in a lookup table and stores the data. So that could be done on, say, customer ID ranges, etc. It's pretty simple, it's easy to implement, and it can support a range of queries efficiently. However, you can get data skew and hotspots if some ranges are more popular or larger than others. And so that can affect the performance and scalability of the system. So again, the selection of the specific data that you want to use for that sharding is super important, so that you don't choose a range that's going to impact the performance, scalability, or cause hotspots. Hash-based sharding is interesting. So it involves sharding a database using a hash function. And I'll include a link actually to what hashing is if you're not familiar with the term. So that the hash function maps a sharding key to a shard. The hash function generates a random and uniform distribution of values that determines which shard to store the data. For example, if a database contains customer data, it could be sharded by applying a hash function to the customer ID and assigning it to one of n shards. Now, the reason why you would do that over just using the customer ID is that what happens is the process of the hash-based sharding gives it a little bit more randomness to the sharding. So it's more balanced, it's scalable, it avoids data skew and hotspots. But it can make queries more complex and less efficient because, of course, you've got to look up the hashing in this hash table. So that can sort of present its own set of challenges in there. So again, all things considered, it is really important as to, one, obviously, you're implementing sharding to scale out, but two, what are the best ways of doing that reflect the nature of the data that's stored in the database? And remember, I'm using a really simple example here. We're talking about database systems that could potentially have multiple tables that are, split up in various ways. So I'm going to rattle off some popular database management systems now. So you've got MySQL, MariaDB, Microsoft SQL, Oracle DBMS, PostgreSQL, MongoDB, Redis, IBM, DB2, Elasticsearch, SQLite are just a few of those. Now, the point is that I'm not going to go into each one individually and say, oh, this one natively supports sharding and this one doesn't, but it's important to understand for whatever database system you're thinking about using or using, what abilities does the database system inherently have to handle sharding. So some will support sharding natively, others require some sort of external tool or add-in, and others still might require actual custom, like hard coding, to implement any form of sharding. And obviously the sharding ability of the database is, you need to say to yourself, well, okay, here's what the database can do. What factors are going to affect how well I can achieve sharding? So things like, sharding strategy, how is the data partitioned and distributed across the shards, and how, depending on what I want to do I want to do it range-based, list-based, date-based, directory-based, hash-based? How does my DBMS allow that to happen? What sort of sharding keys can I use? Am I able to take advantage of? What sort of query language is in there? And how does that interact with the database? How is that affected? How does that perform under whatever sharding options I have available to me? And then, what other replication systems are in place as well? And also, like things like other, with any system, like a database system, it's probably existing within a wider server system that has its own scaling out features as well. So, like, maybe there's some scaling out features that I can use instead of sharding, which get around the problem. So, again, when you're thinking about sharding, thinking about it as a concept, and think about, is there something else that I could do that achieves the same goal, and I don't have to do sharding? And as I've said, there's a number of systems that do not support sharding natively, so you might have to do that through code. Maybe they support sharding indirectly through the addition or the purchase of additional add-ins, plugins, third-party features, and maybe they just do it natively. And so, of course, that's all part of the consideration for anything you do. Now, getting my own sort of personal story weaving into this, it does actually involve file sizes. So I do accept this is before the term sharding was used in this circumstance, but the moment I heard about what sharding actually is, I thought this bears scary resemblance to a a bit of a problem I came across when I was involved with doing rollouts. I worked for a firm, we were a value-added reseller for an accounting system. I won't say which one. And we had this problem where a client that we'd acquired had their database lock up. Their previous provider, who was actually using the same accounting system, had sort of ghosted them and just disappeared off the face of the earth effectively. And they were in pretty dire straits. The database had got above, so the native database system that was the back end to the accounting system that they were using had a file cap on it of, I believe it was 2 gig at the time, and there were various reasons why that was the case, that it had that, and they were all tied in with what was going around in terms of versions of FAT at the time, to be like backwardly compatible with various people's systems. The company that provided it, it was decided that at that time the native file system structure would have a maximum file size for the database. That's the whole database, not individual tables, but the whole data container of 2 gig. And what happened was they got to this value. They were doing a lot of, what was it called? I'm trying to think of the term of it, but it was like order. It was a certain form of both combined marketing and mail order shipping that generated a massive amount of transactions every day. Massive amount of transactions. I think someone said it was something like was it £1 million worth of sales every day? It was some ridiculous amount. Order fulfillment was the term I was looking for. So it was like a massive form of order fulfillment. And they tried some workarounds initially by the classic thing of, like exporting data and reingressing the data into a new container to shrink it, because anybody that's worked with databases knows that the file size doesn't always shrink if you just start deleting files from it. It tends to expand up and it sort of stays there. So the way around that is to export the data, create a new container, and then re-import it into the new container, and then the container will expand up to the new size and then expand from that point. So they'd already tried that trick. The official technique was to move over to MySQL backend, not MySQL, sorry, a Microsoft SQL backend, which would have been sitting on a NTFS server, and then like a Microsoft NT server, where there wouldn't be a restriction on the maximum file size. And again, remember, we're talking about 1998 here. So what was out there? Was it NT4, I think? Yeah, NT4. Maybe NT5. I'm just trying to remember when it went from NT4 to being Windows 2000, and I can't remember if there was anything in between. At that point, I wasn't existing a ton in the server world. We tended to get other companies to set up the servers, or I talked my firm into doing that because we were getting to a hell of a mess, and we just concentrated on the desktop side of things in terms of setting up stuff. In fact, I managed to persuade them to dispense with that and just concentrate on what we were actually supposed to be doing, which was modifying databases and not get involved in complicated desktop rollouts, which is never something that you necessarily willingly want to do. Well, that's my own opinion on that anyway. So yeah, so the solution was to move over to SQL, and the problem would go away by doing that. But in the course of doing that, we had other problems to do with the fact that the server we'd been supplied with, the hardware, was actually faulty. And at that point, when we spoke to the company that supplied the actual original software, they said, "Oh yeah, there's this little known feature which is undocumented, which allows you in the native system in the config file to stipulate how you want to split up data, and you can say, I'd like to create 3 containers just in the config file." It was just a line in the config file. I can't remember the exact syntax, but literally on the native database, you put in the config file, like, I need to split this up to 3 containers, and you'd restart and it would start doing it. And that was a proto form of sharding, where the reason for sharding would be, rather than the fact you need to spread it out over multiple servers, is just you need to spread it out over multiple files, because there's actually a limitation on the file size in the native database. And it's one of those things, well, we wish you'd known this about a year ago, because we'd been spending some time like building like an SQL version of the or modifying some of the code to perform better in a Microsoft SQL environment, and been away on a whole load of courses as well, when in reality what we could have done is it would have been just a single line in the config file, and that would have actually solved the problem. Now ultimately the firm would have probably have to have upgraded their system at some point, because the version of the accounting software they were running on was very old, but it just goes to show that there's many, or potentially many, undocumented features out there that can help you out. So yeah, definitely it's worth digging beyond the superficial on many IT related things. So that's really all I want to talk about in terms of sharding. Hopefully that was informative. This is probably how they're going to be going forward. I might do a bit more where I sort of jump around between resources, but I just wanted to have that on the screen and basically talk to the screen for a while as the first sort of full episode, and then take it from there and see how things develop. Now, I did say in episode 1 in the introduction that I was going to talk a little bit about, in this series, what I'm working on this week. And it's a little bit boring in the fact that I'm really just playing around with more queries in Bing. And I thought I'd just share a couple with you. These are more in the area of music discovery again. It's a popular, popular pastime of mine. And so, I won't feel offended if you stop watching the video now if you're not interested at all. But a couple of interesting ones that I put together, which I think people, because this fascinates me. This is one thing, real good use case for Bing is, I love the ability in it to come up with quite complicated scenarios that I wouldn't be able to really achieve through doing my current methods, which is using APIs to do data lookup in either Last.fm or Spotify. And to achieve what I achieve with this, or what I'm able to achieve potentially in Bing, would require a lot of multiple API lookups, which have their own challenges. So here's one I was working on. So I said, I've recently been listening to the bands The Cure and Bat for Lashes. The reason why I chose those two for this example is Bat for Lashes have covered The Cure. The Forest was covered. Can you tell me the most popular studio album for each band? Despite the bands being quite different genres, I've noticed similarities in the overall atmosphere of the bands. You'll get that I'm going with a more conversational style in a lot of my Bing chats. That's intentional, to experiment with that sort of tone and see where it gets me. Can you create a table that lists 6 bands that also have a similarity in the atmosphere, even though they might be from different genres? And for each of the bands, explain your choice of just a studio album by each band that will be considered to be their most popular. There's a lot of repetition you'll notice here. That's because I found that I needed to lock stuff down, and it was doing some weird things when it produced the table, in terms of not really creating a table exactly how I wanted it to do. So I'm really saying, I'm talking about bands here. I'm talking about bands. The thing I'm talking about is bands. And I found that helps. Same with dates. Sometimes you have to keep saying, I'm talking about dates here. The thing I'm talking about is dates and stuff like that. And that will come up in the second example as well, where I've done that. I'm talking about years. The reason why I chose 6 and not 5 is it's useful for flip-flopping. Sometimes it will flip-flop between bands that are similar to the first and bands that are similar to the second. So at least you get 3 and 3 that way. So, but it varies. Sometimes it does exactly what I want it to do, is like pick bands that have some commonality between those two. And generally when I'm doing it, I pick a band and then a band that's done a cover by that band. And it's quite interesting. You can get some fun combinations. I'm trying to think, like the Norwegian band Enslaved, I think did a cover of someone like a Röyksopp cover. So you could do Enslaved and Röyksopp. Another one would be the band that's already there, which is The Cure and I think Carpathian Forest, who did a cover of a Forest. In fact, loads of bands have done a cover of Forest. So we've got Radiohead, Portishead, all the heads. No Motorhead though, sorry. Depeche Mode, Bjork, Arcade Fire and Lana Del Rey, including a nice little description here. So yeah, but yeah, sometimes with band choices it makes more sense than others, but I thought that's an interesting way of thinking about music discovery, saying, yeah, I like these two bands, and to me there's some sort of commonality here, and you can see that it's even doing that. It's saying, well, they have dark, moody and emotional songs that exploit this. Okay, are there any other bands that fit into that category? So that's one thing to experiment. I'll include these in the description section of the video. And this is very interesting, this one. And again here you can be a bit more specific with the subgenre. I tend to like using the term subgenre. So it could be a subgenre of rhythm and blues, or a subgenre of jazz, or a subgenre of metal, or a subgenre of rock, or a subgenre of punk. But I'm doing here a subgenre of music, so I'm getting it to pick it. So firstly, can you pick a random subgenre of music? Secondly, can you pick a year when that subgenre first became well established? You could use other terms like gained recognition or gained chart popularity, depending on what you want to achieve. Then create a table that lists 5 bands from that subgenre and year that each had a popular album out that specific year. And create a table with 5 bands from that subgenre and year that each had a popular album out that specific year. So again, it's going, yes, it's the year I'm talking about here. The year's really important. Did I mention the year's important? Because again, I've had it break out of the year and just randomly suggest popular albums from all over the shop. So yeah, this idea of restating something. I've seen it being used in AI that does pictures. That's where I got the idea from, but there it repeats it over and over and over again, like the year, or whatever it is it's trying to get it to paint. If you do it like that, where it's just one after the other, it can get a bit shirty with you and say, you know, no need to repeat this. So I'm spreading the repetition out. And again, this is something you can experiment with. You know, if you don't take my word for any of this, okay? Try it and see, you know, take this out and see if it misbehaves. Remember, we're pushing this right on the limit of what it might be able to predict. And so that's when you get these interesting instances of, as I call it, making shit up, or I suppose what would that be? MSU, hallucinations to some people. And for me, I find that a real fascination, because in some areas where you're not necessarily interested in a truthful result, it creates a really interesting creative result, and stuff springs out. Now here, obviously, I wanted to get the years right. Now you can see we've got a bit of wibble here. Is that a term? Wobble. Yeah, so it's saying 94. Now, I'm giving it a bit of a hard time here, because, you know, if you're asking a person who's knowledgeable about these things, when you've got these 3 essential things, we're saying, okay, yeah, pick a subgenre, or what year was that really popular, or what albums were out that year in that subgenre. There's a bit of mental gymnastics going on there, which the methods of large language models don't replicate. They don't really replicate that. They might give the illusion that that's what's going on, but they're not doing mental gymnastics, not by any stretch of the imagination. And as a consequence, they're trying to sort of squeeze thing in to get some sort of semblance of an answer based on the criteria and the restrictions you've put on. So this is still useful. It's hovering around that date. I've seen it do other clever things where it started listing like demo albums. When I tried it with sort of subgenres of metal. That was one it tried at the time. So again, you can repeat this several times. You can repeat it with a subgenre or a genre of a particular type of music that you're familiar with, and then sort of see where it takes you. That's what I normally suggest. You wipe its memory, and then you try it again, and you see basically what happens there. Now, one of the reasons why I'm keeping this fairly low, you've seen me probably do it with, I don't know if you've ever seen me do it with 10, but it is quite nice, I find, if you can get it into a single bubble of a result. You see, different type of thing here. So the table's slightly different. And again, it's something I've seen before. There's no problem in it doing that. In fact, sometimes it's nice if it overstates the table, because you can then see where it might be going wrong. So according to it, all of these albums came out in 1991. I think that's right, actually. It's first Smashing Pumpkins albums. Again, you'd have to just fact check this if you're being really. But again, it's even if they didn't quite, it's around that period. It makes an interesting list here. So yeah, hopefully that was intuitive. So yeah, basically, just to wrap it up, in this video, chatted about the crested subject area of database sharding. Spoke a little bit about like a personal story that still gives me traumatic flashbacks when I have flashbacks of databases locking up and firms losing £1 million of sales a day. Those sort of things tend to take their toll on you. And then just finishing off with something that I've been working out on this week. So hopefully you've enjoyed this episode. It probably turns out it's quite long, but I think that might be the way these are going to go. Thanks once again for watching. Bye for now, and I will catch you in the next episode.